So I just took these 6 sample means and I put them into a list right here. So it's remember this. So the sample means are 51, 52, 53, 53, 54, and 55. I put those 6 sample means into a list right here. And this list right here is the sampling distribution for the sample size of 2, because it's just the means of all possible samples of 2 people. The second step of method 1 is to find the standard deviation of all of the sample means that we calculated in step 1. So how do we find the standard deviation of these 6 numbers? Well, the first step in finding a standard deviation is to find the mean of the values. So we need to find the mean of these 6 numbers in our sampling distribution. We can do that by just adding the 6 numbers and dividing the total by 6. So 51 plus 52 plus 53 plus 53 plus 54 plus 55 equals 318 divided by 6 is 53. So the mean of these 6 numbers is 53. The next step in finding the standard deviation is just subtracting each value by the mean. So we're just going to subtract each of these 6 numbers by the mean of 53. After we subtract each number by the mean of 53, the column of answers will be our deviations. So I'll calculate the deviations right now. I just calculated the deviations. All I did was I subtracted each of these 6 numbers by 53, and these are my 6 answers. The next step in the standard deviation formula is to square each deviation. In other words, the next step is just multiplying each deviation by itself. After we multiply each deviation by itself, we'll have a column of squared deviations. I'll do that step next. So I'm just going to multiply each deviation by itself. I'm going to multiply -2 by -2, -1 by -1, 0 by 0, 0 by 0, 1 by 1, and 2 by 2. I just finished multiplying each deviation by itself, and my column of answers is my column of squared deviations. So -2 times -2 is 4, -1 times -1 is 1, 0 times 0 is 0, 1 times 1 is 1, and 2 times 2 is 4. I just made a mistake. This is supposed to be 4. The next step in finding the standard deviation is finding the mean of the squared deviations. So I'm going to add the squared deviation column and divide the total by the number of squared deviations. So this column adds up to 10. If I added all 6 numbers, it would add up to 10. And now I'm going to divide by 6 because there's 6 of them. In this type of a problem, you don't drop it down by 1. When we're finding the standard error, we don't drop it down by 1. The only situation in which you would drop it down by 1 is if you were finding the standard deviation of the values inside of a particular sample. For example, if we wanted to find the standard deviation of these 2 numbers, in this sample we would use n-1. So we divide by 6 because there's 6 of them. There's 6 squared deviations. And 10 divided by 6 is 1.67, or roughly 1.7 if you round. And after you find the mean of the squared deviations, the last step in finding the standard deviation is getting the square root. So we have to find the square root of 1.7. And it comes out to, I have to hit the square root key, it's about 1.3. That's our standard error. So that's the answer to this problem. The standard error is 1.3. Now we're going to go through the second method of finding the standard error, which is using the standard error formula. And the first step of this method is finding the standard deviation of the population. Finding the standard deviation of the individual people in the population. Find the population standard deviation. To do that, we need to write out the values of all four population members. And remember that the first step of finding a standard deviation is finding the mean of the values. So we have to find the mean of this column of values. We can do that by adding the four numbers and dividing the total by 4. And the answer is 53. The next step in finding a standard deviation is to subtract each number by the mean. And when you subtract each number by the mean, the answers are called deviations. So I'll calculate the deviations right now. This is -3. This is -1. This is +1. This is +3. Next, we have to multiply each deviation by itself to get our column of squared deviations. That's the next step in the standard deviation formula. So we're just multiplying -3 by -3, -1 by -1, 1 by 1, and 3 by 3. That'll give us our column of squared deviations. This equals 9 because the two negatives cancel out. This equals 1 because the two negatives cancel out. This equals 1. This equals 9. That's our column of squared deviations. The next step in finding the standard deviation is finding the mean of the squared deviations. So we just add the column of squared deviations and divide by the number of squared deviations. These four numbers add up to 20. We divide by 4 because there's 4 numbers in this column. And the mean of the squared deviations comes out to 5. That's our variance. And then the last step of finding the standard deviation is just finding the square root of the variance. So we press 5 and hit the square root key. The answer is, it's about 2.24. I'll leave 2 decimal places this time, just to be more exact. So this is the standard deviation of the population. This is the standard deviation of the 4 people in the population. And the symbol for population standard deviation is sigma, so sigma equals 2.24. Now the next step in method 2 is just using the standard error formula. The standard error formula is just this formula right here. It's the population standard deviation sigma divided by the square root of the sample size multiplied by the square root of the population size, which is capital N, minus the sample size, which is little n, over the population size, capital N, minus 1. We already have our population standard deviation, so we can plug that in right here for sigma. So we have sigma is 2.24. We calculated the population standard deviation in step 1, and that's sigma right here. The sample size, little n, is 2 in this example, because we're dealing with all possible samples of 2 people. The population size is 4 because each of these 6 samples came from a population of 4 people. There's 4 people in the population. So this is the population size of 4 minus the sample size of 2 over the population size minus 1. This is always a minus 1. It's just, that's part of the formula. So now we need to work on this square root first.